Let us introduce the round table after the very interesting presentations of this morning, and I will call right away the participants as you see them in the agenda: Giovanni Angius from Snam, Luca Barberis, GSE, Simona Ciancio from Terna, it feels as though I'm a teacher, calling students. Luigi Mazzocchi, RSE, Massimo Ricci from the Energy Authority, Giacomo Rispodieni, and Nicola Rossi from Enel. So we are all here. Allow me to greet you. I'm not going to greet each and every one of you individually. But first of all, thank you for accepting the invitation to be here with us this morning. Our round table comes after 1.5 days of this meeting, so we are coming to see what the situation is. So we started from the announcement of agriculture. This is what we talked about yesterday more specifically. And in this decarbonization process that in which agriculture plays a leading role, there is also a component which is that of energy. We think that energy is our bread and butter. It is our job. But in this broader sector is also a component, and a very important one, because it is part of those revenue streams that come into play in terms of farming role in decarbonization, and therefore it is a very important part of this scenario. So agriculture is not bioenergy, but it has to do with energy. So having said this, what should we talk about today? Well, this session is called Energy and Grids. So we will be speaking about energy, we will be speaking about grids. Biogas and biomethane are an energy source, and a very important one that can be used in many different ways, and that has a very important impact on the system in terms of providing it with flexibility. And today we are going to involve the whole sector. So we've got CIB, the world of research, the grid managers, energy, utilities, regulators. So we can really involve everyone in this debate. And let us start from research, though. So before you do something, you have to, research it and analyze it. So if research is this initial stage of planning and design, we're going to ask Luigi Mazzocchi, who comes from RSE, so the world of research. Let us ask him what is the research sector's vision on biogas and biomethane, which are so important for the evolution of the energy sector.
Buongiorno. Direi che di quello che volevo dire.
So, a lot has already been said by the other speakers. And Mrs. Restek showed a very interesting image, which is quite evident. So you've seen that in the evolution of the electric sector, with a strong portion of renewables and where it should be in 20, 30 years, we see that production peaks are starting to exceed the load. So we need to worry not just about how to make energy, but how to manage the electric grid at any given time. It is a system that it's got its own rigidities, and it cannot be seen as a sum of various energy contributions, so much for energy, solar energy, gas, etc. And in this connection, there is not a real awareness, because the National Plan for Energy and the Climate takes these aspects into account, but not as much as it should. And that is because the strategy of the previous government and the plan do not really focus much on biogas and biomasses. But these have unique features. Of course, there is also hydroelectric, but this is another story. But with reference to the sources that are declared as growing significantly with great prospects thanks to the low cost of plants, production, competitive production costs, etc. we underplay the contribution of gas and biomass because these are renewable energy sources provided that they are done right. So it doesn't mean that producing biogas produces zero emissions, where it depends on how it is made, with what raw materials, what techniques, etc. But if it's done right, then emissions, as far as biogas is concerned, a biogas plant produces 1/10 of emissions of natural gas. So it is devoid of net emissions into the atmosphere. We know that in terms of dispatchability, it is very good, and it's also adaptable to the needs expressed. And we know that in our current regulatory scenario, and perhaps the situation could not be different, but the thing is the biogas plant produces 999 kilowatts, depending on the size, during all hours of the year. Whether there be a high energy demand or not, it continues to do what it was conceived for, that is bringing home its incentive and its energy and incentives with a specific power ceiling. Otherwise, incentives are lost. This is the short term.
So having this limit, having this constraint is becoming something silly, if I may say so. Because since my biogas plant could do something more than its capacity, also something less, well, let's take advantage of this. Instead of doing 1,000 kilowatts, I could do 500 ones and then 1,300 ones. We're not going to harm anyone. We're going to benefit the system. Thank you. We're going to give benefits to end users that will pay less for energy, because all dispatching costs will be recorded in our bill. We are the ones paying incentives, and are going to pay a cent or a penny more. So it's something urgent to do, saying the limit of 999 kilowatts is not going to be applicable anymore, but it's important to have a limit set for the whole year, so that someone else could benefit from the service at competitive prices. We're going to solve a problem and bring down costs. And I will stop here, then I have a few remarks, if I may.
Messaggio efficienza.
Well, efficiency, that's a message. Efficiency in terms of use, flexibility, the use of flexibility that allows you to be efficient from an economic standpoint. So if there's a more valuable market, why shouldn't I chase this value? Bringing value to the system, because I will allow the system to be more flexible. So it's a greater integration and growth for the other sources that don't have these characteristics of flexibility. Flexibility and efficiency also in everything that surrounds management of procedures, management of access, the market, incentives, etc. We know that energy contributes to close the loop of profitability. In the initial phase, growth in the growth of the renewable energy market, we have to come to terms with the greater production of electricity through estimate procedures, market access procedures. So I would like to ask Luca Barderis, what's the vision of GSE with a view to promoting the development of biomethane, because GSE brings a very valuable experience. GSE is managing an important phase of this development and could continue managing it in the future. Thank you, Marco. I would like to start from what Luigi said about flexibility and also the possibility of setting aside a categorization that has accompanied us over the years, posing limits to megawatt generation. Well, the reality of this sector, I'm referring to biogas for the production of electricity, 2,000 plants, 1,400 megawatts, a contribution of 4 terawatt hours to the renewable energy production in the country, is the offspring of these incentives and these incentive mechanisms. Let's have a look at the targets for 2030. Well, we hear a lot about photovoltaic energy, about wind energy, because this expected increase of 40 gigawatts should mostly come from this category. But there are two things to say. First of all, that starting point of 113 terawatt hours normalized at 2017 won't be easily kept over time, because we don't only have to increase our production, but we have to maintain what we have already. Then there are some binding targets, but not binding in terms of potential increase. It is not said that the bioenergy sector should stick to that, should stick to maintaining production capacity rather than developing it only. And the same is true for biomethane. As Professor Zorzoli was saying, this billion is not that much with respect to what we should do. So I think that some scenarios will become clearer over time. So even the potential for development will be clearer accordingly. What is important, in my view, because it is a sector that is mostly the offspring of incentives that have worked very well, well, we have to get out of these mechanisms. Otherwise, we would only limit ourselves to focus on an extension of incentives. If it were so, that would be enough. It is not like that. The question is innovation, development, flexibility, integration with the territory. What Legambiente said is very important, because these assets must be considered as a source of wealth, because photovoltaic and wind can't give services for dispatching, for heating. So biomethane becomes an element of flexibility, because during the day, and I really like the slide shown by the German colleague. Well, the playing field is not what we see today, determined by the base load, but we have production peaks that go beyond that boundary. And I'm sure that Terna will talk about that in greater detail. So there are peaks that can contribute to the replacement of fossil fuels. It's not enough to say, let's close the coal-fired plants, because, of course, the energy produced by the coal-fired plants has to be produced otherwise. There are flexibility characteristics to take into account, thinking of switching without interrupting production activity from electricity production to biomethane, and which can be used in the transportation sector as envisaged by the decree, but as a broader horizon to address here, and I will do that maybe later. Thank you, Luca. So, anaerobic digestion, at least it is what I understood, has some unexpressed potential in terms of characteristics, in terms of capabilities, in terms of benefits for the system. Anaerobic digestion has met very well the needs of the first round of incentives. So if there were the condition to unfreeze unexploited characteristics, I think that the sector of anaerobic digestion, especially in farming, would respond accordingly and successfully. And as stressed yesterday, this is a benefit for the local areas, for the local communities, because a biogas plant is bringing back to local communities the resources that have been fed into it in the first place. And I think that's a very important message for us, for our conclusions, for our day, and for this event. This being said, let's talk about networks. It's no secret that the European Association of gas and electricity carriers or transport carriers are exchanging views. It's no secret. There's an interlinking plan, a big interlinking plan. Something was published recently about this, because gas can produce electricity, electricity can produce gas. Well, the grids have different characteristics, and the combination of the two grids can create a greater value with respect to two separate grids for the whole system. So in this framework, we would like to hear from our two major transport carriers, Terna and Snam. Who's going to break the ice? Maybe Terna first, because we've got a lady here. Good morning. Well, for the future, what we see is to have more flexible resources. They can be dispatched already, because in a world characterized by considerable growth in renewables, there will always be times to manage peaks, and TSO will need to call plants on board that can dispatch their energy, that don't depend only on natural sources. Well, in all the scenarios, what we see is that the contribution of gas-fired plants, and of course biogas-fired plants, is essential, because in the development scenarios done with Snam, or between Terna and Snam, we always see a great contribution by gas-fired plants and dispatchable sources. What the representative of Lega Ambiente said a minute ago is also very important, because today biogas plants can participate in pilot projects, allowing to guarantee flexibility and to get something in exchange for flexibility. Well, market regulation in general and the electrical market regulation in general is opening up to these new resources, because the more flexible resources the TSO has, the better the management of the system. As Marco said, it's no secret that we are exploring some possible development scenarios with Snam. There was a recent workshop organized in Rome, attended by Snam and Terna. And future scenarios have been presented for future needs. It's a work in progress. On the synergies of the gas sector, of the electrical sector, I'm referring to the power to gas, will be taken into account in the next scenarios. We started to work on those that are the so-called development scenarios, so a bit more aggressive than the scenarios that we see in the business as usual environment. Thank you very much. I will start with a slogan. An efficient integration between grids will be possible if the electricity and gas markets are efficient as well. So an efficient integration calls for efficient markets, and efficient markets need certain principles, certain criteria that are also listed in the clean energy package, which has been in part voted already by the European Parliament. First of all, technological neutrality and the market, especially an electricity market, capable of solving a relevant problem, an important problem today. We are witnessing wholesale prices going down and retail prices going up. So the systems need investments. And so political administrative decisions become more and more important than market decisions. Why am I saying this? I think that in the national climate and energy plan and in the national energy strategy, when envisaged that bioenergy does not play a role in the growth of the necessary capacity to achieve the target of renewables by 2030, whereas this role is granted to wind and photovoltaic energy, there is also a methodological and philosophical mistake. Solar, wind and photovoltaic energy has reached very competitive prices. Bioenergy has very high prices, as shown in the National Strategy Energy document. So the new capacity will be mainly resulting from wind and photovoltaic energy. So what's missing? What's wrong with this judgment? First of all, there's one thing being neglected. This energy cannot be dispatched, so integration costs are incredibly high. If you make a few calculations of the investments needed to integrate wind and photovoltaic wind transportation networks, distribution, pumping, balancing costs, etc., and then you break these down across the energy produced by wind and photovoltaic energy, and you add it up to the generation costs, you will see that system costs in general are not that far from biomethane-fired electricity co-generated with other sources of energy. Then I will make some remarks regarding the state of play of the biogas sector. Under ideal conditions, where biomass is obtained sustainably at low costs, where the technology that is being used reach global efficiency conditions. So let's say a sector of biomethane that is highly efficient with sustainable biomass from biogas done right, with high efficient cogeneration, could reach total system costs that are comparable to the photovoltaic energy today. I'm not that convinced that the future of the electricity sector of biogas, but above all biomethane, can be limited to delivery of flexibility services. Well, I think that the technology available, if the costs are suitably calculated, so the technology allows us to represent a clear picture of the costs. Once, of course, the costs have been clearly distributed. With respect to the biogas sector, there's one remark I would like to make, and I will make it now. Well, the electrical generation through biogas should make a quantum leap in terms of efficiency. In biomethane equivalent, 2.3 billion cubic meters of biomethane were being produced. Plants are used with a global efficiency of 50%, 39 electrical and 15% thermal. What's the solution? Well, the solution is the conversion to biomethane, the injection into the grid, and of course the dispatching of this biomethane where there are the thermal loads, because the big problem is that where there's no relevant thermal load, there can't be global efficiency. So it's, I believe, to be part of the sector myself. So it's some criticism I'm making to yours truly. So it's important to change the way the scenarios are analyzed, because there's a political responsibility here. But in general, there is sort of delay with respect to the most recent literature regarding the analysis of integration costs and the breakdown of costs to the generating causes. And there's also a problem of the needs of the sector that should be closer to the end consumers using high efficient technology.
Grazie Giovanni, anche ogni elemento.
Thank you, Giovanni. So putting together the two grids means to create a system with less constraints, and it can, of course, be much more efficient. This is the principle. So it's useful to hear about even critical aspects, etc. It's true that small generation of electricity from biogas is less efficient than others, but we should also look at the biogas plant in the broadest possible manner. So where do the grids meet, at the macro or at the micro level? And experience tells us that the biogas plant is a micro plant in which the two grids, electricity and gas, meet, and where there is this contact between electricity and gas, with the bonus that everything is renewable. And what lies behind this is not just renewable, but also carbon free. So if you look at the micro as something inefficient, or just looking at the micro as a panacea, is not what we want, really. We must look at this system as something that should be evolved, promoting efficiency, putting the two grids into contact. So, of course, they can be integrated at the micro or macro level. In between, it's more difficult. But also, if we refer to the topic of markets, then we have to move on to the utilities, because there are producers, there are distributors, but then, at the end of the day, there are users, and the utilities represent this bridge. First of all, because they are the main engines behind decarbonization. If we want to look at this, they've got their own goals, and they bring the markets in this direction. And then also because the utilities are those that bring this value of decarbonization to the users, because renewable energy is then dispatched to the users through contracts with the utilities. So the role of utilities is essential. And here we have the two main utilities in Italy, and in Enel and Eni. So we would like to know what their viewpoint is concerning this decarbonization process which we are going through, and what their role is, their vision, And if you want to say something about my biomethane, of course, we're more than happy to listen to them. So let us begin with Enel. Good morning to everyone. I prepared a couple of charts that I would like to share with you because they are helpful to, share with you data and also forecasts. My first observation is the following. Renewable energy sources are no longer a dream or an ambition, but they are a reality in the sense that they are a way both economically and environmentally sustainable to produce electric power. This is already happening and is increasingly going to happen even more in the future. And I wish to share a consideration looking to the World Energy Outlook and looking at what this said in 2008 and what the World Energy Outlook says in 2018, which I think is very interesting. In 2008, the World Energy Outlook forecast installed power from renewable in 2017 of some a little more than 1 gigawatt, 1.1 gigawatts, and an installed power at 2030 of some 2.4 gigawatts. This was the forecast in 2008. But if we look at what the World Energy Outlook states in 2018, so after 10 years, we see that in 2017 the actual installed power was 2.3 at world level, so the estimates of 2008 were wrong by 2, a ratio of 2. If we look at 2030, it's 4.7 gigawatts, so 2 times more than the estimates made in 2008. But since it was wrong by a factor of 2 in 2017, in 2030 installed power will be much more than what it has been forecast. So the transition towards renewables is a reality. It's already happening, and it will be happening much faster than we expect. And what we expect by 2030 is a production of renewables covering more or less in energy terms, in terms of generation, over one third of demand. So this is a first observation. And another thing that I would like to share with you is the topic that was also mentioned today, which is the theme of flexibility. So if we look at the second chart, we can see that the increased generation from renewable energy sources, so solar and wind, which are non-dispatchable, brings with it a greater demand for flexibility. So if we look at this demand comparing 2017 with 2040, we realize that this flexibility demand will increase by over 50%. And today this demand can be covered basically in 2 ways. With thermal plants, which are going to provide increasingly more services and less production. But if this is the evolution for the future, we need all flexibility mechanisms. So we have to include demand response and accumulation, energy accumulation, not just through batteries, but also with other systems. And this brings me back to a topic that was dealt with today, looking at biogas, a world that I do not know much, but I am discovering it as I'm listening to the various presentations. But this is a world that can provide flexibility services to the system also in an aggregated manner. And when I speak of a system, I don't just speak about transmission system, but also a distribution system, because flexibility in the future is also going to be needed as far as distribution is concerned. And this is related to the fact that many renewables are attached to connected to the grid. at low tension, with low tension systems. This is a very important aspect. It is an opportunity for us who manage the demand response and who are present in Italy, in Europe and in the world. But it is also an opportunity for those who, through biogas, produces energy and it can provide services to the system. With reference to energy storage, and if we move on, I would move on to the to another slide. Yes, this one. We can see here energy storage based on batteries. Of course, this is a solution that in the short term is what it is available, and this is what we are looking at. But if we get back to what I was saying earlier concerning the growth for the need of flexibility, I think the biogas in general, also seen as gas produced by renewable sources, can represent a new storage opportunity with a difference compared with batteries, because today batteries provide the ability to store energy over the short period of time, so we're talking about a few hours. But if we look at needs and opportunities over longer period of time, like seasons or months, so much longer periods of time, which with an increase in the renewables, this is going to happen. This is the power to X. It will represent an opportunity. So please, if you could move forward a couple of slides, because this is interesting to see what we mean by power to X. It's not just power to hydrogen, power to gas, but it can also be power to chemicals. And this brings me back to what we heard this morning about circularity. So the topic of the bioplastics and the circularity is something that will require energy. And so the possibility of storing renewable energy in doing this may no doubt represent a further element in favor of flexibility for the system. Thank you. So these differences between the two systems will provide for a greater flexibility if we integrate these systems. This is a very important message. Eni, which is the national gas industry in Italy, is going to intervene. Thank you for the invitation. I must say that I arrived yesterday towards lunchtime, and this week in London there was the International Petroleum Week. So up until a few days ago we were talking with the Arabs and Russians and North Africans about the various types of oil in order to feed our refineries. My task consists in dealing with the refineries, and so we may wonder what has it got to do with the farming world, the agriculture, etc. Well, I will try to draw a parallel. So we've got some refineries that we feed with fuel with conventional energy sources, and every day we have to provide 500,000 barrels in order to provide fuel to our refineries for everything that we need to produce in our system. So in addition to this, though, what did we do? Over the past few years, we started taking part actively in the decarbonization process. And the first important step made by Eni was that of converting the first refinery in the world from oil refinery to biorefinery. This occurred in Venice. It's the oldest refinery that we have in Italy. It's 90 years old, and this refinery had its economic cycle that was not doing very well, and so it was decided to shut it down and convert it into a warehouse. So it was not convenient anymore to produce petrol and diesel fuel. We could just buy it somewhere else. But thanks to a patent produced here in Milan throughout research centers, and I was director of research for Eni, we converted this refinery. And as a consequence of today, it uses vegetable oils, and we produce high-quality biofuel. So producing biofuel, what does it mean? Biofuels because CO2 was absorbed by plants. When we use a biofuel, we put CO2 back into the atmosphere, but that CO2 that they're partly absorbed. So in fact, you obtain a significant saving of CO2 if you compare diesel fuel with mineral diesel fuel. Today, this biorefinery is being fueled with palm oil, and we are fueling it with fried oils that we recover. So 50% of fried oil collected in Italy today is used already in the Venice biorefinery. We are also making use of some animal fats, and we are also making use of some waste from the agri-food world. And this is just to really focus much more on the topic of the so-called circular economy. So for a few years, we have started along these lines. Now, and again, yesterday, what I heard was some criticism on palm oil. You're saying, oh, you're using that. Yes, but we're also looking at alternatives. And here we have launched an experimental agri-food project in the south of Tunisia, where we have a field of some 200 hectares, and we have sown it in order to produce castor oil, and this castor oil can fully replace palm oil. So if it were to work, we would then need, with the Venice biorefinery and that of Gela, which is going to operate in a month's time, of 1 million tons of biomass. So we're opening up prospects if it works in that semi-desertic area. We will not compete with the agri-food area, and we will recarbonize a part of soil and give an important contribution to this process of decarbonization. But this does not end here, in the sense of our aim at reducing our carbon footprint. And we also launched some projects on the waste-to-fuel line, to start from biomasses, from separate waste collection to produce bio-oils, or starting from plasmics of CSS to produce hydrogen and methanol. So hydrogen could be used in the biorefinery of Venice, where we currently produce it in a different way, and methanol could be another component as hydrogen. They are the building blocks of chemistry, and you can do a lot of things with them. You can produce plastics or fuels. Let us move to the biogas theme. Last year, we have the obligation of placing in our fuels 8% must come from biological sources. This is the obligation we have to comply with. And this 8% is 7.2 with liquid conventional components and 0.8 made of advanced components. And biomethane is considered to be an advanced component. And oil companies last year, we have all adhered to the scheme set out by the law, which said, if you adhere, you pay, you have solved your problem, then somebody is going to produce biogas and biomethane, and as an oil company, you play a part in this system. Well, our role wishes to be something different. We don't want to do just that. We want to be active players. So as Enel, we believe we can do many things. We are good at many things. We manage very complex plants such as refineries, petrochemical sector, and oil and gas prospection in many countries in the world. So we decided to have an active role in the production of biomethane. And yesterday, President Prandini said that we signed an agreement with Coldiretti. Allow me to say something, because with Piero Gattoni we are about ready to also sign an agreement with the Biogas Consortium, as it will be a privilege for us, because we feel very close to this world, because it's a world that produces energy. We use energy, we sell it, and we look for it. And so the synergies between the Enel world and that of biogas are huge. And we could give our own contribution in building many upgrading plants. And these plants, of course, well, we manage much more complex plants, so we would add our skills so that these plants may work 24 hours a day in a safe manner, respecting the environment, and so we can provide our skills to do that. And we would like to begin. The economics seem to be interesting, because then every project has to be sustainable financially and not just from an environmental standpoint. But let me say something important. What do we do with this biomethane? Well, we have some 100 distributors for methane all over Italy. We want to build some other 40 in the next 4 years in our 4-year plan, also because we believe in methane-based mobility. And we think that methane can represent today that energy transition that is so much required. So while all the other systems are being developed, the problem of the decarbonization is probably not something that we should look at, something that we can solve in a single way. There will be many different solutions, but the solution that we see in terms of the contribution of gas, particularly biomethane, is very important because it allows us to use, first of all, existing technologies, and it allows us to use facilities that are already there. We don't need to change the stations. They exist already. We'll just build a few more. We have a gas grid network, which is very good, also thanks to our founder, who at the time had a great intuition. He was very far-sighted when he said that our country needed gas in order to grow, and therefore we have a gas pipe system that is very widespread. So thanks to this network, we can get biomethane produced from small producers, getting it onto the grid. If we are close, we can compress it. If we are far, we can turn it into LNG, and therefore we can cover a demand that, in our opinion, is important for the next future in order to contribute to decarbonization. In addition to this, allow me to add that our refineries use hydrogen. So for us, hydrogen is a very important gas because it allows us to do many things, and it is essential in our refining processes. So how do we produce hydrogen? Today, hydrogen is produced through steam reforming reactions starting from natural gas. Of course, if instead of natural gas we could add biomethane, because it will be available, we can then reduce in the imports of natural gas, which mostly comes from abroad, Russia, Libya, Algeria. So we receive gas from many countries in the world, and on the contrary, we could increasingly use locally produced gas. So I think that synergies between the farming world of cattle raising, cattle breeding, which recovers and produces biogas, it's very easy to then turn this into biomethane, and therefore we want to really focus our attention on this, and we want to play a leading role in the years to come.
Thank you very much. So in Eni's mind, there's not only biomethane, but there is biomethane. That's good news.
Compare ancora il tema del biometano come un vettore energetico multiuso.
So biomethane is a multi-use energy carrier, and this is something very important. The colleague from Enel said we are facing a sort of dynamics that can only be imagined, but who knows what's going to be, and this dynamics has benefits but also needs.
Bene, per chiudere questo giro, diciamo, abbiamo parlato di reti.
So we talked about grids, we talked about markets. Well, there's an entity known as the Authority for Energy. Now the name has been slightly changed, but we are interested in energy today. Well, it does two things in accordance with the law. It regulates the grids, so it tells us how the plants are connected to the grids, how the grids are used, what are the principles governing the development of the grids, etc., and creates the conditions for the markets to work efficiently, so to protect competition on the markets. We've talked about many things today. Biomethane, we've talked about grids, we've talked about market integration. Well, clearly, the regulator, even if we don't see it sometimes, plays a key role in terms of supervision. So what's the view of the regulator when faced with this challenge of integrating energy markets and merging the roles of the grids? Thank you very much, Marco, for inviting me to say something on a question that seems more marginal for regulation than what it actually is. Because obviously regulation does not deal directly with biogas connections, but it has a challenge ahead of it challenge that is very important for us all, a challenge which is mainly linked to decarbonization. We've heard many times the same thing expressed in different terms, and I will express my view as well. First of all, there will be many renewable sources. What are the characteristics of renewables? When they produce energy, it costs nothing. For wind and photovoltaic energy, well, it costs nothing. When they have wind, when they have sun, but when they don't, well, they need something else. So the value of the commodity depends very much on their capacity, and this is true for gas and for electric. And people say services are needed. It's the same thing. What applies is that energy is valuable only if produced when needed. So producing when needed is not something that can contribute to flexibility, but also because there's no need in having a flat production. So the key characteristic of gas, it can be stored at very low prices. And we already have gas storage systems in Italy that are already valuable, and their market value today is way lower than remuneration. So I mean the remuneration of storage is integrated, which means that we have more than what we need today, and that's good news. Because for the future, gas storage will be the only economically sustainable source to do what we heard a minute ago, so to move energy from the summer to the winter, because of course with electrochemical storage we can shift energy in between days or between weeks, but between seasons, of course, it's very difficult. That's the only solution. We can't do without gas, but gas has a problem too, because people say that gas consumption will go down, but this is not true, and you can see that in projections. But even if it went down, well, the infrastructure needed is not going to go down, because maybe there will be less consumption at a yearly level. But if we want to replace coal, we have to replace it with something in the short term. If we ask Terna to try to do it, not today, because they won't answer, but if we think about sun and photovoltaic energy in the winter, you'll see that gas is going to play a key role for them, because it guarantees capacity when needed through storage. And that's the key point to stress. And this is something that we are going to address in the future, because if I try to remunerate availability with market prices, how will I do that? With very volatile prices, zero when there's no need, and very high when needed, and very volatile and poorly foreseeable. Let's think about gas storage. Gas storage is worth 1/5 of the infrastructural costs. So if there are serious difficulties, the gas storage might be worth 10 times infrastructure costs. But I don't know, because it depends on how much I have. If I have more than needed, it's worth nothing. And that's a very relevant element of risk when there are renewable auctions, when Terna guarantees storage, etc. So we are in a world where, paradoxically, we're not sure about how to address those risks. So having investments with very high fixed costs, and in order to have profitability on the market, and some implicit risks. We're talking about capacity, renewable auctions, but we haven't found a structured solutions, because we can find it in a monopoly environment, because what we are saying here, there's lots of technologies where the values change over time. So this is the situation. And gas plays a key role. And biogas and biomethane play a key role. What's the difference between biogas and biomethane? Biomethane is a standard product, so it benefits from a number of things, infrastructure, storage facilities, so it has a structural advantage. Whereas biogas becomes immediately a source that can't be stored. It has some flexibility, of course, for the reasons we mentioned earlier. Two more things. We heard about incentives, and I was thinking of one thing. I don't know how many years it's been since the Chip 6 was an idea that was born at the authority, because the Chip 6 has this type of defect of this problem. It had an incentive number of euros per megawatt hour, but it depended on the market. It was fixed. It didn't depend on the peaks. Well, if we use these plans and we fit it into market conditions, well, we're going to have a win-win room for improvement, giving more money to the operator and spending less to pay for the Chip 6 plant. So I'm pretty surprised that we are still at the same point with this problem. I'm not saying it's not true. I'm saying that it is true, and so it's weird that from a regulatory standpoint nothing has been done to go in the direction you were talking about, because it's something that I think not that difficult to solve. Then incentives, remuneration, costs. In addition to what I said earlier, so guaranteeing cost cover. We're not talking about incentives any longer when we think of photovoltaic auctions, because apparently they cover the costs of these plants. And then we heard about grid parity, as the colleague said in a minute, comparing the kilowatt hours of a source that can produce any time and a flat price, which is very different, especially if I think about recording those quantities of renewable energy. So in addition to the lack of flexibility, there's also a question of energy value that changes over time. So the energy profile becomes key. So the question I ask myself, but I'm not an expert in this field when it comes to these sectors, why can't we think of a positive externality that these sectors have when what you don't use, if not used, will be CO2 in the atmosphere? So we think about funding carbon sequestration, which is great as a future technology. But on the other hand, we are looking for some exogenous incentives on a sectoral basis that have some benefits that can be quantified from an economic standpoint. And maybe going down that road, we could find a form of support which is no longer support because we have to go on for 3 years, but becomes structural, because at the end of the day we recognize also the actual benefit. And this is something that has not to do with the regulatory framework, but it's something that I wanted to point out.
Bene. Nel ringraziare e nel concludere, perché adesso Massimo ha già fatto, diciamo, una degna conclusione.
So Massimo's already drawn some interesting conclusions. So the value of carbon, we heard about this yesterday over dinner. How are we going to place more value on carbon sequestration in a natural manner? This is a very important thing. And to conclude, the Chip 6 that was mentioned, not everyone is familiar with that. We know that very well because I was there too, but there's a difference with respect to the Chip 6. Well, back then, the Chip 6 with the anticipated termination was actually exploited by someone who took the money and flew to the Maldives. So the plant is not efficient, I'm going to pay a bit less, or what you would get at the end of the day, give them the plant and you can go. But the people were getting the money, so people were exploiting this to go on holiday. Well, in farming, this does not happen. Those who have land behind the plant are not leaving. So what I mean is that bringing the current production sector, this opportunity to grow is not money that is distributed wrongly. It's something that can be done with no great fear of losing these funds, or actually placing more value on many of the characteristics we heard about today. So thank you. If you don't have any other remarks. With respect to the Maldives that you mentioned, joking aside, Since we mentioned the resolution chip 6 that as GSE we have experienced in the first person, there's a very important carrier operator that with that money of that resolution, I won't mention it, but it's going to went very important investments in the hydroelectric power photovoltaic sector, becoming one of the most important carriers in renewables. So this is a virtuous example of reconversion of a chip 6 plant that was not renewable that has turned renewable. Maybe someone flew to the Maldives actually, but not everyone. Someone worked really.